Okay. Assalamualaikum warahmatullahi wabarakatuh. Okay. Um, today, not today, right now, I'm going to give you some tutorial and also an explanation about some kind of our last kind of finite automata without an output that we have an NFA. Epsilon NFA. Okay, next. So today we will going through to the learning objective, not that long, and going to the introduction, the conversion, and also the finite automata application. Next, so in this week material, you have to be able to explain concept, definition, construct, and also convert the epsilon NFA into a equivalent NFA. So this will be very important in your next material. Next, we're going to the introduction. Next, so we will recall what is the properties of the NFA. So as we can see here that we have two states. The first one is the starting states, and then the second one is the final states. Then in this diagram, we can see that this is a very important things that we have in NFA. What's that? That each of states that have one input, it can have more than one next states. Here, as we can see that for the transition for A with the input of 0, then we have A. Then the next one, we have another A to the input of 0, then we also have a B. Then these things, we call it by an NFA. In DFA, you cannot do that, right? Yeah, that's the difference. That's the difference. Okay. Next. Okay, so what is NFA? NFA is a non-deterministic finite automata, and then it has a characteristic of non-deterministic, which is uncertain, multiple choices, and can branch. Then non-determinism transition means at any steps the machine may branch into multiple states. As here you can see that from states A with the input of 1, we have two next states. For the input of 0, we have two next states. That's all. Then the biggest difference between the NFA and DFA is in the transition function. In in DFA, we have delta Q times sigma, it goes to Q. But in NFA, it maps to a set of states instead of one states. Then the acceptance rule is that if at least one possible path ends in a final state, it is accepted. So you don't need to going through all of the path, but if one of the path is clear or is accepted, then it's done. Okay, then the power equivalence, NFA and DFA is having the same power. Okay, NFA and DFA has the same power. Okay, next we have what is the epsilon NFA? Okay, so the epsilon NFA is actually it should be an epsilon NFA where we still have our same 5 tuples with the Q, sigma, delta, and blah blah blah, so on. But the important things here, the first important things, what is the difference on the transition? So in the transition, we have a big differences here. We have a epsilon. In NFA, for the transition, we just have times Q times sigma. It's going to power of Q. In this case, we add some epsilon. Okay? Yep. It means that each of states with a certain input, we can have an epsilon. So in this case, before in the NFA, we cannot have this epsilon going to another states. But in this case, in the epsilon NFA, we can do it. So if I have a string of 0, 1, it can be accept or not. The answer is yes. Accepted. Why? Since we have 0, then we have an epsilon, which is we can go through we can go to C. We can go from A to C through B. Even if we have an epsilon here. Okay, then we have an 1, and it's a final states. Then the second one, this is the first one. The second one is the final states. In epsilon NFA, for the final states, we have any states either is a final states itself or can reach a final states through one or more epsilon transition. Okay, so in this case, in epsilon NFA, we can have more than one final states. Okay, and this is the third one. Every state on epsilon goes to itself. For example, we have a A, we have a B, we have a C, right? Then we have a 0, 1, and then we have, for each of this, it contains an input of epsilon. Okay, nice. We go to, so we go to the conversion of the epsilon NFA to an DFA. So what is the most important things in the conversion? So before that we have a conversion from a DFA to an NFA, the most important here is the transition table. Okay, right? Same with the DFA to NFA, the conversion of the epsilon NFA to a DFA, to a NFA, we also need a transition table. Then, to get this transition table, we need an epsilon closure. We have to determine, right? What does it mean? What does it mean? Let's start to draw an transition table that we know before. So we have input of 0 and 1. We have 3 states, A, B, and C, as A as the starting states. Then if we do like before, like a transition table in DFA to NFA, we what we do is that from step A, from state A that have an input of 0, we go to A. Then A with the input of 1, we go to nothing. Then B go to 0, A go with the input of 0, we go to epsilon. And then B with the input of 1, we go to B, and so on. But this one is incorrect. So this is not what we will do in this case of the conversion of epsilon NFA to NFA. So this is not what we will do. So what we will do with this, we have to make the epsilon closure. So how can we make it? Okay, so we have also transition table, but we have to add some epsilon closure and then the input, okay, input and then epsilon closure. In this state we have a states. Okay, in this case, so we have to first we need the transition of this one. So A, from states A, we have an input of 0. So in this case, we have to make from states A, we have an input of 0. So, okay, let's try. Sorry. Let's try. Here we have an states A with the input of epsilon. What do we have? A with the input of epsilon, we have a B. Okay? But you have to remember that each of the states has with the input of epsilon will go to itself. So don't forget we have A and we have a B. Okay? Okay. Then where do we have next? We also have a C. Why? Since from A we have an input of E, then we go to B. From B we can go to C with the input of epsilon. So we have A, B, and C for the input of epsilon. Then from from states A, we erase this first. Okay. From states A with the input of 0, we have A, right? Yeah. How about B? From B with the input of 0, we do we have a empty string. Okay. Next, from C, we delete it again. From C, we have an input of 0, we go to C. Then from A, okay, enough. Then from A, we have an input of epsilon. We go to A, we have an epsilon, we have a itself, and also B, right? And also C. Okay, don't forget the C. A, B, C. How about the empty string? Will we given an empty string? How about C? How about C? Let's check. How about C? It will go to itself. Okay. So in this case, we can see that the transition table or the transition from A with the input of 0, we have A, B, and C. Since we have an A, B, C with the union of C. So we have an A, B, C. So we can draw it here. We will use another color. Resemble orange. A, B, and C. Okay. So we go next to the. Let me erase all of this. Okay. Then we go with the red color. Okay, we have same things. We have e-closure. We have a input of 1, right? And closure. The stats is A. Still right? Okay. So right now we're going to finding out the transition between A from stats A with the input of 1. Okay, so A. Forgot to delete this. Sorry. Yeah. Okay, so from A, we have an input of epsilon. We have itself, right? And B. And C. Okay. So we have an A, B, and C. Next step for A. For A, with the input of 1, we go to empty string, right? B, we have an input of 1, we go to B itself. C, we have an input of 1, we go to itself. Then from empty string, we have another input of epsilon, it will be input string, empty string. And then from B, we have an epsilon, we go to itself and C. Itself and C. For C, we have an input for itself. Yeah. So in this case, we will have a B and C. So the transition from stats A with the input of 1 is B and C. Okay. Next, delete this. Okay, let's have a red. So erase this one. Okay. We have another transition table with the closure with a 0 and closure. What do we do now? We have to finding out the transition from stats B to with the input of 0. So we write B here. Okay, from B with the input of epsilon, we have itself, right? Sorry, itself and C. So we have B, C. Okay. So and then from B with the input of 0, from B with the input of 0, we go to empty string, right? From C, we have an input of 0, we have a C. Then from empty string, of course, we have an empty string. From C, for the input of epsilon, we go to itself. So in this case, we have a C. Then we have to write it here. Okay. Let's go to delete all of this. Right? And then this one. That's all. And we add some. We use a red color. And right now we will, forgot this. Then we have an input of 1. We have to finding out the states from B, the transition from states B with the input of 1. Then from B, with the input of epsilon, we go to itself and C. Then from B, we have an input of 1, we go to itself. For C, we have an input of 1, we go to itself. Then next, from B, with the input of epsilon, we go to itself and C. For C, we go to itself. Okay. Then in this case, we have a B and C for the transition. Then we have to write in the transition table. Okay. Let's delete the states, all of the results, and the input. Change to red color. I forgot to erase this. Okay. Then we go. We continue with the input of the state from state C with the input of 0. We go to put here first. From C, then from C with the input of epsilon, we go to itself. Okay. Then we don't have any other next step for the input of epsilon, right? So next we continue with the C with the input of 0. Where should we go? C. Back to itself. Then for C, we have an input of epsilon, go to itself. Then we have a C. Sorry. A. Okay, then we move to another input of 1. Let me erase this first. Oh, forgot. Change the red color. We move it to 1 for the input of 1. Then we have to finding out the transition between the states C, from state C with the input of 1. Then from C, we have an input of epsilon, we go to itself. From C, we have an input of 1, we go to itself. For C, we have an input of epsilon, we go to C. Then we found a C. Okay, we got the full transition table. Then we have to erase all of this. Okay. Then we have to I erased the brackets. Okay, so we have to drawing the transition the diagram of NFA, of the equivalent of NFA. Equivalent NFA. Okay, let's start. Oh, sorry, we have to determine the final states. Here we have, which one is the final states of epsilon NFA? Is C, right? But before, if you remember that here we see that the final states is NFA is any states that either final states itself, or can reach a final states through one or more epsilon transition. Okay. Then in this case, C, of course, because it's the epsilon NFA final states. Do we have another? Sorry. Do we have another final states? Let's check it out. Check from A. Okay. Check from A. Check from A. Then from A, we have an epsilon to B. We have an input of epsilon to B. Then from B, right? We have another input of epsilon to C. Oh, this is the final states. So we have this. Fulfill this requirement. Then it means that A is also a final states. How about B? Let's check once more. From B, can we reach the final states, the previous final states, with the epsilon transition, with the epsilon input? The answer is yes. So it's also a final states. So we have in this case we have three final states. Okay. Let's draw the new final states. Okay, we start with the A. Okay, from A we have an input of 0. We go to A, B, and C. B, we have input of 0. We have to input of 0 to itself. Also, we have an input of C. Okay. From states A, we have an input of 1. We go to B and C. Okay. Sorry. B and A to B, and then B to A to C. Next, this one is done. Okay, the first row is done, and then the second row. From states B, we have an input of 0. We go to C. From B, we have an input of 0. We have a C. We go to C. Sorry. From B, we have an input of 1. We go to B and C. B, okay, B to itself, right, and C. Next, from C, okay, we have an input of 0. We go to C. Okay. Then from C, we have an input of 1. We go to C. Okay, so here it is, the diagram of the equivalent NFA. That's all. Okay, don't worry that I have the answer, of course. Oh, forgot the final states. Should be a final states. All of them are the final states. Okay, let's do it this. This. Okay, so here is the answer, and this is the DFA, so it's the equivalent. Okay, so we have another example. Okay, we have another example. We have an example 1. Sorry. We have an example 1, so we have 4 states. 1 starting states and 1 final states. Then we have a sigma of 0 and 1, of course. Sorry, with the epsilon. Okay, let's start. Let's start to do some exercises. Okay. Let's make the first transition table. Okay. Then we go here with the, we have input of 0, and then we have another epsilon, and okay, so we have, so first we're going to do the, from stats A we have an input of 0, we go to blah blah blah. Okay, so we have A here. Okay, then from A with the input of epsilon, with the A we have an input of epsilon going to itself. Okay, going to itself. Then does it go not to another state? The answer is no. So we just have a A. Then from A with the input of 0, we go to B. Okay, right? B. Then from B we have an input of epsilon, we go to it, of course, itself, and C. Okay, B and C. Then we have a B and C. Okay. Then we go to next. Sorry. Not straight enough. Okay. Then we still have a from stats A we have an input of 1. So let me erase some of the drawings here. Okay. Then from A with an input of epsilon we go to itself. Right? Do we have another states from A with the input of epsilon? No. Okay. Then from A with the input of 1 we go to epsilon. Empty string. Then from empty string, of course, we will have an empty string. So we give an empty string. Okay. Next, we will still use the same transition table, but we just give a line here. Okay. Then we go to the next what do we call it? Next row. Okay. So we start with the B. Okay. We start with the B. From stage B, we go to from stage B with the input of 0, we have a blah blah blah. Okay. So we start with this transition table. From B, we go to the epsilon. From B, we have an input of epsilon. We have a itself, of course, and to C. Then from B, we have an input of 0. We go to empty string. Then from C, we have an input of 0. We go to itself. Then from empty string, we have an input of epsilon, of course, empty string. From C, we have an input of epsilon. We go to itself. So in this case, we have an C. We have a next stage of C. Then we go with another with another from stage B we have an input of 1. Where do we go? So for B, okay, the first step we have to finding out the next stage of B with the input of epsilon. If we go to itself, and then it will go to C. Okay, from B with the input of 1, we go to itself. Then from C, with the input of 1, we go to D. From B, with the input of epsilon, we have a transition. We go to itself and also C. Then from D, we have an input of epsilon. Of course, we go to itself. So in this case, we have a B, C, D. Okay. Next, we have the next input. Let me do this. Okay. The next row, we have a input of C. We have a state of C. Then from states of C, we have we are going to finding out the next states of from the input from the state C. We have an input of 0. Then we have an input of 0. Then we have to finding out the next stage of starting state C with the input of epsilon. Starting state C with the input of epsilon. Of course, we have a itself. Do you have another? No. Then from C, we have an input of 0. We go to itself. Then from C, we have an input of epsilon. We go to itself. So here we have a transition of C. Then we go next. We have to find out the next stage of transition C with the input of 1. Then first we check out that the C with the input of epsilon, we go to we go to itself. We go to itself. Then from C with the input of 1, we go to D. Then from D with the input of epsilon, we go to itself. Then in this case, we have a D. Okay, now last. Next, we have the next row. We have the next row. From stage D, we have an input of 0. Then we go to this table. We write from stage D. From stage D, we have an input of epsilon. We go to itself. From D, we have an input of 0. It's an empty string. Then the empty string will be empty string. Then we go to finding out the transition of transition of D with the input of 1. Then D with the input of epsilon, we go to itself. Then D with the input of 1, we don't have anything, so it's empty string. And empty string, of course, will be empty string. So we have an empty string and we have an empty string. Okay, that's all. This is the transition table for the NFA. Okay, so next we have to make some NFA diagram. Oh, before that, we have to determine which one is the starting states. Okay, starting states, of course, A. Then we have to finding out the final states. Before the final states, we have D. So of course, in this case, we also have D for the final states. But we have to finding out whether we have another final states or not. Okay, first we check from states A. Okay, so from states A going to states D, from states A going to states D, do we have do we have a way to go to D with the input of epsilon? Okay, let's check. Do we have? No, okay, right? So it's not the final states. Then we go to A. Sorry. Okay. A, not this. Okay. So A, not these things, huh? Should be this. Sorry. Okay. So A is not the final states. How about B? Let's check B. Oh, we have a way with the input of epsilon. Okay, so we can go to C. How about C to D? Do we have a way? No. You don't have an epsilon way. So this is also not a final states. Then next, the last one, we will go to C. Then how about C? Do you have any way to the final states, the initial final states? The answer is no. So this one is also not the final states. Okay, so the conclusion is starting states, we have an A. Okay. Final states, we have a T. Okay. So let's draw some diagram. We start with the A, right? We start with the A, then from A with the input of 0, we have a B and we have a C. Okay. With the input of 0. Then, okay, this one is check it out. Let's check it out. So A with the input of 1, we don't have any thing. So we don't need to draw this. Okay. Next, we have from B with the input of 0, we go to C. Then from B, we have an input of 1, we go to B. Okay, B, C, and D. Where should I draw D? Okay, let's just draw here. Okay. Next, we have a C. From C, with the input of 0, we go to C. So we have another looping here. C, with the input of 1, we go to D. Sorry, not 0, should be 1. Then D, we have an input. We don't have any, so it's empty string, so we don't need to draw that. Okay, let's check. Okay. Okay, let's erase all this to make it still a clear things. Okay, here is the answer. Maybe it's a little bit different with my answer, but it's same. Just different in drawing. Sorry. Okay, so we go next to the next example. we continue to the next example. So in this case, we have three states, okay? Three states with the input. Sorry. Of course, we have three states. Okay. And then we have A, B, and C as the symbols. Okay. And then we have P as the starting states, and then R as the final states. So here we can got here. Okay. Then next, sorry. Okay. It's a little bit longer. So here, let's start. So we have a transition here. Let's draw a transition table with A, B, and C. And then we have a P, Q, and R. Okay, then we have to draw another epsilon enclosure, and then not zero, it's A, and then epsilon enclosure, sorry. Then we have an enclosure, we have a B, and then we have an enclosure. And last one, we have let's do a little bit, no. We have an enclosure, we have a C, we have another enclosure. Okay, let's start. Let's start. P with the input of A, right? P with the input of A, okay? P with the input of A. We write a P here. P with the input of epsilon, we go to R. It should be the itself, P, and then R, and then Q, right? Q, R. Then from P we have an input of A. From P we have an input of A. Let's erase this first. Input of A. P with the input of A, we don't have anything, so we have an empty string. From Q, we have an input of A, we go to B. Okay, from R we have an input of A, R, we don't have it, so it's empty string. This one will be empty string, this one will be empty string. How about the P? P with the input of epsilon, we go to R and Q, and itself, P, Q, R. Then we can write here P, Q, R. Okay. Then we go next to the next input. Okay, P. From P with the input of P, then we have to check P with the input of epsilon. Okay. With the input of epsilon, we have a P, right, to itself, Q, and R. P, Q, and R. For P, we have an input of P. We have an input of P. We go to Q. P with a Q. How about Q? Q with the input of P, we go to R. R with the input of P, we don't have anything. So then from Q with the input of epsilon, Q with the input of epsilon, of course, to itself, right? And nothing. Then we have a Q. Then from R, we have an input of epsilon, we go to it itself. And this one would be empty strings. So we have a R, Q, QR, sorry. QR. Next, we have a P here for the input of C. Okay. Then P with the input of epsilon, same, right? Same like the other. What do you mean? Okay. Same like the other. We have a P, right? We have a Q. We have a R. E, Q, R. Okay. Let's see. For P, we have an input of C. We go to of C, we go to R. Okay. Q with the input of C, we go to P. R, we have an input of C, we don't have. Then from R with the input of epsilon, we go to it itself. P with the input of epsilon, we go to itself, we go to here, then we go to Q. So P, Q, R. Then right here, P, Q, R. Okay. Oh, plus 1. R, we have an input of C. This one should be, one should be an empty string, and then we have an empty string. Okay, why is it going, what's going on? Okay, yep, let's check. Wait, let me check. P with the input of C, go to R, okay. R with the input of epsilon, we go to it itself. Q, we have an input of P, Q, epsilon, then from Q we have an input of C, we go to P. Okay. Oh, of course. Also this, I forgot. This should be P. Should be P, Q, right? And then Q with the input of epsilon, we go to it itself. Then we also have a R here. Okay. Yeah, that's good. P, but the results the same. PQR. Okay, PQR. Yeah. Then we go next to sorry. Okay, next we have a Q. Q with the input of A. Okay, with the input of A. we check the Q with the input of epsilon, with the epsilon, Q with the input of epsilon, we have itself. Q with the input of A, we have a P. Then P, we have an input of epsilon, we have a P itself, R, and Q. Q, R. Of course, here we write a P, Q, R. Okay. Next, we have a key here, Q. Next, we will check this P input. Okay. From key with the input of epsilon, we have a Q. And Q with the input of P, we go to R. From R with the input of epsilon, we have a itself. So we can write here R. Okay, next. Q with the input of C, where do they go? Okay, let's check one by one. From Q with the input of epsilon, Q epsilon itself, right? Then from Q with the input of C, we go to itself. Then we go to B. And it should be B first in order. I like to be in order. Okay, B and Q. Okay, P with the input of epsilon, we have a P itself, Q, and R. B, Q, R. How about key? Q with the input of epsilon, we go to itself. Okay, so we have a P, Q, R. Next, okay, we have a R. R first. Okay, R with the input of A. Then from R with the input of A, first we have to check the R with the input of epsilon. R with the input of epsilon. R with the input of epsilon. R with the input of epsilon, go to itself. R, we have an input of A, we go to empty string. Then, of course, from empty string, we have another empty string. Okay, we check the transition for R with the input of B. Input of B. Okay, R, first we have to check R with the epsilon. R with the input of epsilon, we go to itself. Then from R with the input of B, we go to empty string. Then from empty string, of course, will be empty string. Next, last, we have to check the transition between R with the input of C. Okay, first R with the input of epsilon, we go to itself. R with the input of C, we go to nowhere. So it will be an epsilon, empty string, then epsilon, empty string. Then empty string, empty string, empty string. Okay, let's delete. Let's delete all of this so we can continue to drawing the diagram. Okay, we draw the diagram. Okay, before we draw the diagram, we have to finding out the first initial states, of course, P, then R, is the final states. And then we have to check whether P or Q is also a final state or not. Then we check, first we check the P. From P, okay, check. From P, we have we have an epsilon here. So from P, we can directly go to R and accept the string. So that's why we also have a P as the final states. Then how about Q? Let's check. Let's check. From Q, can we go to R with an empty string? The answer is not. So this is not an empty string. Okay. Then we go to draw the diagram. First, the initial states will be still a P. Then from P, we go from P with the input of A. With the input of A, we go to, of course, P. Then we go to Q. We go to Q. Okay. Don't forget the P is the final states. Okay. Q. Then from P with the input of A, we go to R. Then from P with the input of P, we go to Q. Okay. P. And then R. P. Next, P with the input of C, we go to P, okay, C, Q, okay, R, okay. Next, the second row from Q, we have an input of A, we go to P, okay, A, and then we go to Q itself, okay, looping. And then we go to R. That's all. And then Q with the input of P, we have a R. Then from Q with the input of C, we go to Q with the input of C. Go to P, okay, and Q, okay, and R. Okay, that's all. Sorry. This is the diagram of equivalent e-NFA. Okay, so you can check all of the answer in the next page. Here it is. So this one is the epsilon e-NFA, and also this one is the equivalent e-NFA. Okay, next. For example 3, you do it by yourself. Then you have to check whether your answer is correct or not, and same as what we draw here. Okay. Then we go to the last section, which is the finite automata applications. Okay, so first of all, let's open this. Okay, the finite automata applications. So before, this should be an NFA. Okay, so before we study, we already learned about the DFA, which used in a situation where there is a clear deterministic sequence of states and inputs. So if the sequence and states or an input is fixed, then you use the DFA. What is the example? The example is a traffic light, the vending machine, and microwaves. For traffic light, we knew that the states is there are 3 states. For the first state is the red. Okay, then we go to yellow, and we go to green, and so on. For a vending machine, we have For example, before in the last meeting, I gave you an example of a vending machine that just accept a quarter or maybe nickels and dime, and a microwave, yeah, so on. Okay, so and then the second one is NFA. For NFA or non-deterministic finite automata is useful in the scenarios where it's a multiple option and path can be explored. Okay, so for example, we have one states with the same transition. Sorry, with the same input, we go to the different states. Maybe we have add here. Yep. So this is an NFA. So what is the example? The first example is the GPS route calculation. Why? It's because that in a GPS calculation, we can have option 1. We have an option 2, for example, and so on. Option 1, it's the fastest, for example. Option 2 is the shortest. So yeah, here it is. Maze solving robot, it's the same application as the GPS route calculation and the web browser with the back and forward buttons. Next, we have an epsilon of NFA. It applies in a system where an automatic transition happens without explicit input. For example, elevator idle modes, smart home system, and automatic doors that respond a sensor. Most of the things in the world now we use an epsilon and alpha. Okay, so that's all for today. That's all for today. I hope that this short tutorial is giving you a little bit explanation, and maybe next week, no, not next week, maybe tomorrow I will give you, not tomorrow, maybe in Spada you have to check whether I will give you an homework or not, and have a great weekend, and see ya next week.